So today we're going to be looking at gravitational potential energy. So gravitational potential energy, we're going to call it PE for short, is the second type of mechanical energy. Potential energy is the energy a body possesses because of its position. It can be thought of as stored energy. Now, often people will just refer to it as the potential energy and not the gravitational potential energy. That's strictly not 100% accurate, because there are different types of potential energy which aren't necessarily due to the position of the object. For example, the energy stored in a spring under tension is a type of potential energy, but it doesn't matter the position of that spring. Also, a rubber band that's stretched has potential energy, but that we're in mechanics we're thinking specifically about gravitational potential energy. It's the energy that could be released if the body falls. So say we had some mass, and here's our base level, which could, in most cases is going to be the ground, and that body has some mass in kilograms, and it's a height h from the h meters off the ground, off the base level. The potential energy is going to be given by the mass times g, 10, times h, or we can think of it as 10 mh. And again, it's measured in joules. The potential energy that a body possesses depends on its height, therefore. The height is measured at this base level. So at the base level, down here, the potential energy is going to be 0, because the height is 0. Now we can have, now say we had a table, here's our table, and it's on the ground. Now if we had a ball up here, and we're going to drop the ball to the ground, the distance that that ball is going to fall through is this height here. So the PE, potential energy of the ball, is the mass, is like 10, is 10 times whatever mass this is, times this height. If the ball, the height down to the ground, we'll call it big H, that's going to be different, but the potential energy that ball has isn't 10 times the mass times big H, because the ball isn't falling to the ground, it's just going to fall onto the tabletop. So therefore we need that's what we mean by this base level, and defining what we mean by the height. It's not always necessarily the ground, so you need to be aware of that and make sure you're defining your height accordingly. Let's do an example. Find the increase in potential energy in raising a sack of mass 1 kilogram through a height of 3 meters. So the increase in potential energy is going to be the mass times g times the height. So it's 1 times 10 times 3, which is going to be 30 joules. Now, when a body, so if say we've got our got some height h, and we've raised some body up, which has got m kilograms. The work done against gravity is mgh joules, and the increase in potential energy is mgh joules. The potential energy increases when work is done against gravity. So objects at a higher level have more potential energy than those at our level. So say we've got, this is h1, and we have another body with the same mass, but it's at h2. This body has got more potential energy than that body, and that's completely logical. When the same body descends through the vertical distance h, the work done by gravity, when the body descends through h meters, the work done by gravity is mgh joules, and the decrease in gravitational potential energy is the same, mgh joules. What matters is the vertical height from the top to the bottom, and this is what matters is the vertical height. So if you think of, say we've got a slope and the ball's going to go down the slope, what we're interested in is the vertical height between the top and the bottom. So I hope that makes sense.